Object-centric models aim to obtain separate distributed representations for the distinct objects that are present in the input. These models have often been tested on simple datasets where the objects are visibly well-defined. But in this paper, we want to find what are some useful inductive biases to extend these models to more complex scenes. We do this by applying neural style transfer to two datasets. Using this, we focus only on the change in texture of the objects and are capable of using the underlying ground truth factors to perform the crucial evaluation of the performance of the models. We evaluate slot attention and Monet, which approach the separation of the objects differently and are very well known in the literature. Monet uses an attention module to find the shape of the objects and separately reconstruct their visual appearance. Instead, slot attention reconstructs both shape and visual appearance with a single module. We evaluate the representation quality and the ability of the models to separate and reconstruct the objects separately. Now, qualitatively, we observe that Monet achieves very high reconstruction performance, but does so by hyper-segmenting the image, focusing solely on distinct colors in each slot. Instead, slot attention blurs out the reconstructions a little bit, but separates the objects correctly. So inspired by this, we attempted to improve Monet by blurring the reconstructions, but we observed that separation is still problematic and the model keeps prioritizing the colors. In slot attention, when reconstruction performance is improved, and so we have less blurring, the objects are still separated correctly. We can verify these observations objectively by looking at the ARI, which is a measure of separation performance, and this is very low for Monet, while mean square error is very good. Even its mean square error, when this matches the one from slot attention, which we managed to do with our modifications, the ARI is still not improved. And the separation performance can be seen, it is very strongly tied to the actual information that is available in the representations. So in conclusion, we have observed that Monet struggles to balance the two modules that separately reconstruct shape and visual appearance during training, while slot attention finds this balance more easily and therefore avoids hypersegmenting the input using a single module. Good separation is strongly correlated with having the model learn good representations. And finally, during optimization of the models, we have confirmed that the representation bottleneck is not a sufficient mechanism to regulate segmentation performance.